Alright, so this video covers conversions. Conversions are a way for us to move from one unit to another unit. That's a conversion. Often people get it mistaken with any sort of calculation, but these are only calculations that move from one unit to another unit within the same measurement. So one length unit to another length unit, or mass to another mass unit, something like that. So we're going to start with the most basic one, and this I call do as they do type conversion. First, you need to know a conversion factor. Conversion factor is the number that represents how many of one thing is another thing. For example, 1 meter is equal to 3.28 feet. That we would call a conversion factor, okay? So if I was going to try to convert a certain number of meters, say 20 meters, and I want to figure out how many feet that is, I have to use a conversion factor. And in this method, which I again call do as they do, we look at the conversion factor to figure out what to do. Here, I'm trying to get from meters into some number of feet. So what I'm going to do is actually take a look at the conversion factor and see what they do. Here, they have 1 meter, and it becomes 3.28 feet. How could you possibly get the number 1 to become the number 3.28? Sure, you could add, but in this case, we're always going to multiply or divide. So how would you multiply or divide, or what would you multiply or divide to get 1 to become 3.28? I would multiply by 3.28. So because you're going from meters to feet, you do the same thing. So 20 times 3.28. Got it? So 20 times 3.28 would be 6.56. That's times 2. So we got to make sure our decimal place is in the correct spot. 65.6 feet. All right? So same would be true if I went the other way around. So let's take a moment. Let me erase our example. And let's try going the other way. Let's pretend I had, say, 80 feet, and I wanted to figure out how many meters that was. 80 feet equals some number of meters. Well, here I'm going from feet to meters. So I go from feet in the conversion factor to meters. How would you go from the number 3.28 to the number 1? The easiest way is to divide by itself. So we divide by 3.28. So the same thing is true here. We do as they do. 80 feet becomes meters by dividing by 3.28. That's it. That is converting using the do as they do method. All right, the second method of conversion that I'm going to teach you is called dimensional analysis. Dimensional analysis works a little bit differently in that you give your conversion factor in the form of a fraction. So for example, 1 mile is equal to 1,609 meters. If I take that conversion factor and I put it in the form of a fraction, either 1 mile over 1,609 meters, or 1,609 meters over 1 mile. In both those cases, that fraction is equal to 1. If you remember from math class, anytime you divide a quantity by itself or by an equal quantity, the answer has to be 1, right? So if a mile is equal to 1,609 meters, if we divide them, the value is just 1. This is important based on what we do in dimensional analysis. Let me explain what dimensional analysis looks like. If I take, let's start with 30 miles per hour. I'm going to write it miles over hours because this will help us in this conversion. I want to get this into meters per second. So all the way down here, I'm going to put meters per second. And I got to somehow get the miles to become meters, because that's our length unit, and the hours to become seconds. Well, we already have our miles to meters conversion right there. And I'm going to add the conversion for hours to seconds. Well, you might already know how many seconds are in an hour, but I'm going to go ahead and take it step by step. 1 hour is 60 minutes. 1 minute is 60 seconds. And we're going to go ahead and use all of this to convert 30 miles an hour into meters per second. So let's start by getting rid of the miles. So what I'm going to do is I'm going to multiply by the conversion factor set up in a fraction form. So watch what I'm going to do. I want to get rid of miles. So if I multiply it by a fraction with miles down bottom, what happens to those miles? They cross out. Remember doing this in math class. If something's on the top of a fraction and the bottom, they can cancel each other and become the value of 1, so you can just cross them out. So if I put miles down bottom and I put meters up top, I'm left with meters up top, which is really what I want because I want meters per second. So setting up my conversion in this fraction works perfectly. So I have 1,609 meters, 1 mile. Now my units of miles will cross out. So let's do another step. Cross out. Hours. I want to get rid of hours, so I'm going to put the hours up on top because then this hour will cross out. And I'm going to replace it with minutes. So what's my fraction that I'm going to set up with this conversion factor? 60 minutes, 1 hour. The hours cross out, and I'm left with minutes. But minutes isn't what I want. I want seconds. So I need to do this again. Multiply by some conversion factor, and I'm going to give myself a little bit more space here, where I'm getting rid of minutes. So I put the minutes of the conversion factor on top, and the seconds on bottom, because that's what I wanted to end up being, is seconds. So our minutes will cross out. We know that 1 minute is 60 seconds. And look at what units I'm left with. Meters survive right there, and seconds survive right there, which I'm looking for. I'm looking for meters up top and seconds down bottom. So how do I then get my answer from this? Well, 30 times 1,609 is on top, so that's just over 48,000. Divided by 60, because the 60 is on bottom, which is like 804, and then divide by 60 again, which gives us our answer of 13.4. And our units are meters per second. So dimensional analysis allows us to convert by multiplying by conversion factors set up in fractions. But this conversion factor just equals 1. This just equals 1. This just equals 1. Which means it's okay. I'm not changing the value when I multiply it by 1 every time. Okay? So I did it by saying 30 times 1,609 because it's on top, divided by 60 because it's on bottom, divided by 60 again because it's on bottom. And I get my answer, 13.4 meters per second. Now it's your turn to practice.